Hello, this is lesson 8.4, and we're going to be looking at concepts in probability. So first, we're going to define some set operations for events. So we have event E and F that are events for a sample space S. Now, if we have E intersection F, so this right here is the same thing as intersection. That occurs when both E and F occur. So this one is, actually, let me do it over here so that I have a little bit more room, intersection and, or both. So if we think about an intersection in, real world, we've got the two streets crossing each other. So an intersection is here. That is where we have um, both at the same time. Okay, next one is E union F. So event E union event F, where that occurs when event E or event F or both occur. So this is when you see the word or, you know that you're using the union. Next one is the little hyphen here, or I'm sorry, it's not a hyphen, it's apostrophe, which this is complement, so they're complementary. That means when event E does not occur. So you see the word not is when we use the complement. Okay, let's look at rolling a two standard dice and finding the sum. So if we think about two dice here, um, we can kind of, we've got numbers 1 through 6 on either one of them or both of them. So there we go. When we roll both, if we get a 1 and a 1, that sum is 2, right? So our sample space here starts, or the smallest number is going to be 2 because it is a sum. Then we've got 1 plus 2, which is a 3. Next one is going to be 2 plus 2, which is a 4. Next, 2 plus 3 is a 5. 3 plus 3 is 6. 3 plus 4 is 7. 4 plus 4 is 8. 4 plus 5 is 9. 5 plus 5, 10. 5 plus 6 is not 6. 5 plus 6 is 11. And then we've got 6 plus 6, which is 12. And now I know that there's a lot of, empty boxes in this grid, but if we do like 1 plus 6, that's 7. Well, we already have the 7 here. 5 plus 2 is 7. So these are all the numbers that are. Then we've got our, doubles here as we roll the die. So those are all the different sums that we can get. Now, this right here, so this is asking how many possible outcomes are there. So if we count, we've got 1, 2, 3, 4, 5, 6 columns, and we've got 1, 2, 3, 4, 5, 6 rows. 6 times 6 is 36. Okay, next we're going to name an event where the probability of E is going to be 1. So that means that these are events that are the outcome is going to be anywhere between 2 and 12. So 2 is less than or equal to sum is less than or equal to 12. Because 1 means that it happens for sure. 0, probability of 0 means that it's not going to happen. So for example, if we say the event is where sum is greater than 12. Well, we can't have a sum greater than 12 because we only have a 6 and a 6 as the largest numbers on the die. Okay, next one is name 2 events that are complementary. So this was the one where it is not. So for example, if we say that the event is sum is less than or equal to 7, complement of this would be the opposite. So sum is greater than 7. And 7 can only be included in one of those. Okay, let's move on. We've got the following events here. So we have event A, sum that is even, event B, sum that is odd, and event C, sum that is less than 8. So we're still using those two die here. Now we're gonna describe each compound event. So A intersection B, that means that the sum is even and odd. Remember that the word and goes with the intersection. Next one is the A union B, which is the or. So sum is even or odd. Okay, B intersection C, sum is even. No, I'm sorry, not even. Sum is odd, of course, because it's B. And less than 8 from right here. So what does this mean? It means that we can have the odd numbers that are less than 8, so 3, 5, and 7 for this one. Okay, next one is B union C. So that one, B is sum is odd, so sum odd, or C is less than 8. Now, remember the word or. So the difference between the and the or is that we can actually have, so everything that is less than 8 would be 2, 3, 4, 5, 6, and 7. And then, or odd. So the ones that are greater than 8 are going to be 9 and 11. Okay, next question. Which compound is a sure thing? So remember, a sure thing means that the probability of the event is going to be 1. So a for sure compound event is going to be the event A union event B. So this is for sure going to be 1 because if we think about sum, even, or odd, well, all of these sums are going to be even or odd. So that is for sure. Now, which compound event is impossible? Well, if you look at this one right here, can a sum be even and odd? No, it cannot be. So this one is impossible. So that means that the intersection of event A and B is going to equal 0. Okay, next, which events are complementary? Well, if you think about what we just looked at, impossible and sure thing, or actually the impossible, we looked at event A and B. So those are going to be complementary because it's either a even or odd. There's nothing else. Okay, next one. Um, without doing calculations, what do you know about the probability of um, B intersection C? So where's our B intersection C is right here. So what we know is that it's 3, 5, and 7. Um, so we know that that one um, is possible, and P is not going to be 1 for B intersection C. And if we look at the probability of B union C here, some odd or less than 8, well, it's the same thing. They're both possible, and neither one is going to be 1. Now, this next question is, which will be greater? Well, if we look at what we've got here in B intersection C, we've got 3, 5, and 7. B union, we have a lot more numbers, so that has to be greater. This one is a higher probability. Okay, so next one, we're going to talk about disjoint events. Events E and F are disjoint events if E intersection F is empty, an empty set. So two events are disjoint if they cannot occur at the same time. So if we look at this Venn diagram here, our event E is 4, 5, and 6, and our event G is 1 and 2. So those are two totally separate numbers. There's nothing, they're not, the circles are not on top of each other. There's a gap between. So those are going to be disjoint. Are the whole thing, all the whole all the numbers in this box are going to be 1, 2, 3, 4, 5, and 6. And now, yes, there is no intersection. So our probability for E union G, not union, intersection, I'm sorry, is going to be a 0. Now, of events A, B, and C on the previous page, which are disjoint? So which would be a 0? If we look at event A and B, odd and even, those are going to be disjoint. Less than 8 is going to have even and odd numbers, so that's not it. So events A and B are the ones that are disjoint here. Okay, next we have basic probability principle. This is the same thing as what we did in 8.3 where we talked about theoretical probability. So let S be a sample space of equally likely outcomes and let event E be a subset of S, and then the probability that event occurs is the number of outcomes in event E divided by the number of outcomes in the sample space. So just a caution, the basic probability principle applies only when the outcomes are equally likely. So make sure that that's happening when you're doing the calculations. Okay, we're still rolling, now we're rolling a single fair die, and we're going to find the probability of the given events. So our sample space is going to be 1, 2, 3, 4, 5, and 6, like it is if we're rolling a single fair die. Now, our event E here is getting a number that is a multiple of 3. So multiple of 3 would be 3 and 6. So the probability of this event E is going to be 2 out of 6, which simplifies to 1/3. Now, not getting a number that is multiple of 3, that would be our complement of event E, which would have 1, 2, 4, and 5. And this would be the probability of the complement of E is going to be 4 out of 6, which is 2/3. Okay, let's look at event F, getting a number greater than 4. So our event F would be greater than 4, 5, and 6. So the probability of F is going to be 2/6, which is 1/3. Now, getting a number less than 4, notice that less than 4 is 1, 2, and 3. This is not a complement. Why is it not a complement? Because neither one of these include 4. So 4 has to be included in one of them in order for them to be complements of each other. So the probability, so G, event G is 1, 2, and 3. So probability of event G is 3/6, which is a half. And if we, add these two up, we should get a 1. Well, 2 plus 3 is 5, so that's not it. So these are not complements. 4 is equal. So 4 doesn't belong to either one of them. It should be. Okay, next we're going to look at addition rule of properties. So for any events E and F from a sample space S, we do the probability of E union F, which is probability of E plus probability of F, minus the probability of E, the event E intersection F. And that is, we do this so that we don't count this one twice. Okay, so let's look at an example. We have an American roulette. So it is the croupier spins a marble that lands in one of the 38 slots in a revolving turntable. The slots are numbered 1 to 36 with 2 additional slots labeled 0 and 00 and painted green. Half the remaining slots are colored red and half are black. Now, make sure that you understand that not even on this. So find the probability that the marble will land in a red slot or an even number. A red slot or an even number. So what we're doing is we're calculating, okay, probability of red or even. So probability of red plus probability of even. And then we're going to subtract probability of red and even because those are included in both the red and the even. So we want to subtract one set of those from here. So how many reds did we have? If we have numbers 1 through 36, and we could count them, half are red and half are black. So 1 through 36, that means that there's 18 out of 38 plus 18 out of 38. And we need to subtract the ones that are red and even. So the ones that are red and even, 1, 2, 3, 4, 5, 6, 7, 8. We're going to take away the 8. Now, hold on a second. 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes, there are 18. Yeah, yes, I'm sorry, I got stuck. So the 38 comes from 36 plus 2. And then, so we're subtracting the red and even. So we counted 8, so 8 over 38. And when we do this calculation, we get 28 over 38, which simplifies to 14 over 19. Now, next, we're going to find the probability that the marble will land in a black spot or a number that is divisible by 3. So, probability of black or divisible by 3. So, probability of black plus probability of divisible by 3. And we are subtracting the probability of black intersection divisible by 3. Okay, blacks again, we've got the 18 over 38. Divisible by 3, we need to figure out what numbers are divisible by 3. Let me take these off, these marks off. Here we go. So divisible by 3, 27, 12, 18, 6, 33, 9, 30, 15, 24, 36. Did I miss anything? 1, 2, 3, 4, 5, 6, 7, 8, 9. I did miss. What am I missing here? 2, 14, 35, 23, 4, 16, 21. So 18, 6, 21, 33, 19, 8, 12 is divisible. 29 is not. 25, no. 27, 36, 24, 3, and 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, there should be 12. So 12 that are divisible by 3 out of 38. Now, the probability of black and divisible by 3. So we're going to go ahead and look at the black ones. Well, maybe I should not have done that. I did it. Anyways, so there's 33, 6, 24, 15, and I think that's it. So there are 4 that are black and divisible by 3. So we want to take those one set of 4s out because they're included in this 18 and they're included in the 12 as well. So when we do the addition, we get 26 over 38, which is 13 over 19. That's a 19. Okay, next one here. We're going to look at fatal vehicle accidents. So let A represent the probability that the driver was age 24 or younger. Let B represent the probability that the driver had a blood alcohol content BAC of 0.08% or higher. Find the probability that the driver had a blood alcohol content below 0.08%. So B represents the probability when it is high 0.08 or higher. So we are looking for the complement of B. So 1 minus, that's how we calculate the complement. And we're going to take the probability of B. So everything that's inside the circle B, so 0.330, actually there should be a 0.0330 plus 0.1318. So 1 minus 0.1648, which is 0.8352. So the probability is 0.8352. So every time we take a complement, we do 1 minus the probability. Now, our next one is find the probability that the driver is 25 years old or older. So A is 24 and younger. So what we're looking for is the complement of probability of A. So we're going to take all the numbers that are not in A. So 0.1318 right here and 0.6800, and we get 0.8118, and that is our probability. Okay, next one is find the probability that the driver is less than 24 and has the blood alcohol content greater than or equal to 0.08%. So this one is the intersection of A and B, which is right here, 0.0330. That's the intersection that's covered by both A and B. Next one is find the probability of driver is greater than 24 and has blood alcohol content less than 0.08%. So what we're doing is we're going to take the complement of A intersection B. So that means this number right here that is outside of A and B, so 0.6800. I'm not sure why the page cutoff is funny on these, but not sure what's going on. Anyways, okay, next one, we're going to look at odds. So odds in favor of an event E are defined as the ratio of probability of event E divided by the probability of the complement of event E. And notice that the complement cannot be a 0 because we cannot divide by a 0. So find the odds of the event occurring from the given probability that a bachelor's degree recipient in 2014 majored in a specific discipline. So natural sciences and mathematics. The probability of event E is 2 over 25. So remember, it's odds in favor. Natural sciences and mathematics. So 2, what's left, which is 25 minus 2, which is 23. So this number comes from 25 minus 2. Now, for social and behavioral sciences, probability is 3/20. So odds in favor is going to be the numerator, 3, 2, and we're going to take the denominator and subtract the numerator from it, 3 to 17. Okay, next, a single fair die is rolled. Find the odds in favor of getting these results. So 2, 3, and 4. We have a single fair die. So our sample space is 1 through 6. This, we've got 3 here. So the rest is 1, 5, and 6, which is 3 as well. There's 3 values in the what's left out from 2, 3, 4. This can be written as 1 to 1 because it simplifies to 1 to 1. Okay, a number greater than 5. Well, there's only one number that's greater than 5. That would be the 6, so 1. And the rest of the how many do we have after we take that 6 out? We've got 5 left, so it's 1 to 5. Okay, convert the given odds to the probability of the event. So now we're doing the opposite of what we did right here with these. So odds that tax revenue comes from sales and gross receipts are 7 to 13. So our probability, the first number is going to be the numerator, so 7, and then we're going to add these two, which gives us 20. 7 plus 13 is 20, so it's 7/20. Same thing here. Odds that tax revenue comes from corporate income tax are 37 to 963. So our probability of this event is going to be 37 divided by, and we add these two numbers and we get 1,000. So 1,000 goes down here. Okay, that's it for this lesson. Let me know if you have any questions. Bye.